Viscosity is a measurement of the resistance to flow. So whenever you hear the word viscosity, always think resistance to flow. Let's consider the viscosity of some liquids that we are all familiar with. We will pour the liquids into a 1-liter beaker, which is the same as a 1,000 milliliter beaker. A quart is 946 milliliters. So we will have no problems pouring all the contents of this quart of milk into the beaker. Notice that the milk pours easily. There is a low resistance to flow, so our viscosity would be low. Milk is a low viscosity liquid. Now let's try an antibacterial hand soap. Note that the flow of the hand soap is significantly thicker than the flow of the milk. The hand soap has a high resistance to flow, and therefore a high viscosity. What about Gatorade? Would you expect Gatorade to have a low resistance to flow or a high resistance to flow? Well, as you can see, Gatorade has a low resistance to flow. It pours easily into the beaker. Therefore, it has a low resistance to flow and a low viscosity. When students are asked to give an example of a liquid with a high resistance to flow, they will often think of honey. Honey at room temperature usually flows somewhat slowly out of its container. And if the honey has been refrigerated, as you see here on the screen, it will have a very high resistance to flow, and therefore a high viscosity. Notice how slowly the honey flows back to form a level surface in the beaker. This is a characteristic of liquids with high viscosity. What about a Diet Dr. Pepper? A high resistance to flow or a low resistance to flow? I think we'd call this a low resistance to flow, and therefore a low viscosity. Here's a frustration that practically everyone has had at some time or another, trying to get ketchup out of the bottle. It's difficult to do because ketchup has a high resistance to flow, and therefore a high viscosity. If you're ever taking a test and you get confused about viscosity, just remember that ketchup has a high viscosity.